Hi, welcome to Raw Math. Today I'm doing a series of videos of solving systems of equations using Gauss Jordan Elimination. So that involves using a matrix. So if I want to use a matrix, I should probably start off with writing out a matrix. Now when I write a matrix, I need to have a column for all of my variables, my x's, my y's, and my z's. My first equation doesn't have an x. That doesn't mean we have a hole in the matrix. It means we use a 0. So my first equation is 0x plus 4y plus 1z equals 2. Then I have 2x plus 6y minus 2z equals 3. And lastly, 4x plus 8y minus 5z equals 4. I use brackets to make it a matrix. I use a line to make it an augmented matrix, that line representing the equal sign. Then what I want to do is I want to create a matrix with ones along the main diagonal and zeros in every other place. To do that, I have to actually have a 1 available. So what I'm going to do is I'm going to switch these two rows around so that I actually can have a 1 there. So I'm going to make this row 1 and this row 2. And I'm going to pivot on this 2 to zero out the 4, because if I want 1s along the main axis and zeros everywhere else, this is 1, 0. I need that 4 to be a 0 as well. So I'm going to take row 3 and I'm going to subtract 2 times row 2. So row 3 is 4, 8, negative 5, 4. And negative 2 row 2, notice I do a negative, not just a 2. I want to make sure that I'm adding down. It helps with the success of all of our basics. Negative 2 times row 2 is a negative 4, a negative 12, a positive 4, and a negative 6. When I add down, I get a 0, negative 4, negative 1, negative 2. All right, so then I'm going to come and put these all back into a matrix. My first row is going to become the 2, 6, negative 2, 3. My second row is going to be the 0, 4, 1, 2. And my last one is going to be the 0, negative 4, negative 1, negative 2. Brackets to make a matrix, a line to make it an augmented matrix, and we are on our way. The next thing I want to do is I want to use this 4 to zero out the rows above and below. So to do that, to clear out a 6 with a 4, I'm going to go to 12. So I'm going to say 2 times row 1 minus 3 times row 2. I'm going to actually come through and say 1/4 of row 2. I usually save this towards the end, but I see this 4-1 situation happening. And I am predicting that when I do row 2 plus row 3, interesting things are going to happen, and never trust a teacher who tells you something interesting is about to happen. All right, I'm going to come up here to do my calculations. So I have 2 times row 1, that's 4, 12, negative 4, and 6. Then I'm going to do minus 3 times row 2, which is going to give me a 0, a negative 12, a negative 3, and a negative 6. When I add down, I'm going to get a 4, 0, negative 7, 0. Okay. Then when I do row 2 plus row 3, I can see I'm going to get a 0, a 0, a 0, and a 0. So I'm going to take this and say, divide this by 4, so I have the beginning of what I need, this identity matrix. If I divide this by 4, I get a 1, a 0, a negative 7/4, and a 0. When I divide row 2 by 4, I'm going to get a 0, a 1, a 1/4, and a 1/2. And when I add, 0 plus 0 is 0, 4 minus 4 is 0, 1 minus 1 is 0, 2 minus 2 is 0, brackets to make a matrix, a line to make an augmented matrix. Okay, so what's happening here is we have our x column, our y column, and our z column. And what we really have is x plus a negative 7/4 z equals 0. We have y plus 1/4 z equals 1/2. And 0 equaling 0 means that this is a true statement with infinite solutions. So to get this infinite solutions, what we're going to do is we're going to say, hey, let's let z equal t. This is a parameter. This means if we set t to a value, we can figure out one of our infinite number of solutions for this system. This ends up becoming x minus 7/4 t equals 0, or when we add this over, x is equal to 7/4 t. For our second line, we have y plus 1/4 t equals 1/2. When we subtract this over, we get y is equal to 1/2 minus 1/4 t. We now have all the pieces we need for our parametric answer. Our x is 7/4 t, comma. Our y is 1/2 minus 1/4 t, comma. And z is our parameter t. There you go. We have our solution. I hope you've enjoyed the video. Please subscribe to my YouTube channel, like my Facebook page, and I will see you on the next video. Thanks.